Think we lost them, turn the wheel off. Hello, my fellow YouTubers. Listen, tonight's going to be some conversation. I want you guys to just get a couple more people on. We'll start the topics for tonight, and I'll just give out a little hint. Get yourself recognized, man. Whoever's popping in, give a shout out. Get a little recognition going. We'll have some chat tonight. We want some conversation on this tonight. Tonight is we're going to take electromagnetism and we're going to stretch it out a little bit, and we're going to come off Ed's wheel. What do you mean no video? All right, so let's do a check here. Does anybody see the video playing? Really? All right, I'm going to bounce off. Mike, you got good video? Mike, come back again. You got good video? Simplester, just go ahead and bounce off, bounce back on. I got to get some peeps up on here because we got some great topic tonight. We're going to take electromagnetism in a different way. Yes, good video, but froze. So, yeah, it froze because I lost the connection somehow. But is it working good now? Is it right now good? Are we good?
All right, so I got some connection. I turned my phone off and put it back on. All right, cool. What I did was I just turned my phone off, put it back on. You know, when in doubt, I always said with computers, turn them off, then turn them back on. So let's get a few peeps on here. We'll wait a minute or two. And tonight's discussion is really, 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 really exciting because we are going to come off of Ed's wheel with electromagnetic induction. And we're going to induct the primary. And we're inducting the primary. It's not connected yet, so we're going to connect it together so you guys could see how I have this set up. We're going to come off this PMH. We're going to go into the primary, out of the PMH into the primary. And to the secondary, the top and bottom here is a LED light. We're going to get this LED to light up. So, what we're going to get into is electromagnetic induction, and then also we're going to talk about sending out signals, some electromagnetic waves, and how we could, what I'll explain and what I'll build down the road, which is like in a couple days, I'll go ahead and build the yoke that Ed had, and we're going to keep that as the receiver. So that yoke, which is hanging from the tripod. And we'll go over to that picture in 1 second. This is cool as heck. Now, what we're gonna do is give me 1 minute. I gotta take a quick pee break. And what we're gonna do is we're gonna charge the wheel up. This wheel is gonna get charged up. It's not connected to anything. We're gonna go to these wires here, and these are little tiny PMHs, okay? Every time you see a colored row, that is the North Pole. Here's all your North Poles. There's 66 turns on each one of these, and these are 16 gauge wire. I got it over 1,500, I think, or let me see exactly what we have here. We have a large amount of 16 gauge wire. So this whole spool went on there, and that's 10 pounds, and it's saying it is approximately 1,256 linear feet. Now we're going to get into, not this video, but we're going to get into wavelengths in centimeters. And we're going to get into meters and then centimeters. And we're going to show tonight that we can send out a signal, pretty much any signal we want, just from the wheel turning by a primary with a secondary. This blows my mind. I did this experiment tonight, and I said to myself, wow, this is a whole different take here, because I want to see if I can electromagnetically induct that secondary coil over there, which basically usually I'm putting 15,000 volts into it, 60 milliamps. Tesla, like a neon sign transformer. And it's coming out electrostatically out of the top like a big pressure valve. Here, I know that I could build the same pressure valve, not 15,000 volts, but yes, I think 15,000 volts, because this is what I'm thinking. I'm thinking that these magnets are more, because they're magnets, the iron on these magnets are twofold. First fold, they are iron. Second fold, they have a crystalline lattice about themselves. The fact that they are magnets, are permanent magnets, and they can be intensified by putting more windings on them, shows me that they'll be saturated like a speaker. And when you have windings around them, and you either excite the winding or the iron gets excited, you're going to have amplification on the outside coming out on the wire every time the poles change in this one pole. So when this pole is approaching, we're going to say down the road here into one of the PMs, it's filling up with all its matter, like little tiny matter. Then all of a sudden, as soon as it breaks free, the matter wants to get back to where it was. So that energy in that matter, we'll call it, or matter, because it is just a particle. So that particle that wants to go back somehow gets back and then creates a whip effect, and that whip effect snaps out of the PMH. So I'm going to get you guys off the phone right now. I don't see anybody else jumping on, but oh well. I'll just bail on the pee break. So let's go to this. This is freaking cool. All right. So we're going to make some connections. I got some shitty ass wire connections here. So we're going to come off the PMH, and I'm going to come off of, I got these connected on the PMH. The two starts and the two ends are connected. So these are in parallel, you would say. And I'm going to come off the two starts, and I'm going to go into into this. Let me move that over a little bit. Into the start of the primary down there, okay? And that's just regular braided wire, about 8 turns. 2, 4, 6, 8 turns. Starts at the bottom of this. This is probably 22 gauge wire. I don't know. Turn wise, I forget the frequency of this, but because it's a 4 diameter, that I believe at the 560 range, the 600 kilohertz, we're talking. And let's come out of the other end of the PMH. And we're going to go to the other side of the primary. So this primary is going to get wang-a-banged by the wheel, okay? And this is what the key here is. We're going to take this and we're going to back it up and see what it does. And then we're going to take it and we're going to move it closer. So how magnets run is in electricity. So we're putting a magnetic field out this way. Let me see up here if I have a visual for my brohams. Can you guys see that? You guys can see this? So this is the field lines of my coils. Now, as soon as I bring this over there, it's probably going to glare out. So let's have a quick conversation here before I move it over. So your norths are always heading outward. They're always pushing out. So there's your pusher. So if you're going to turn the wheel on your pusher, you should be pulling your pusher. So whenever, you can see, cool beans. Whenever you want to turn the wheel, you would have, my finger would be the opposing metal with a coil on it. And that should always be pulling the north, because you're going to get a better attraction and separation. Now see these field lines, how they're always moving away from the north, and then the south is getting it from both ends, and the north is pushing it out in both ends. So we're going to come over here now to the wheel. And let's go, and you can still see that because I can too. So let's try to find a compass. Oh yeah, I knew I dropped one. So I bought these compasses. They were only like, I don't know, $4.93 a piece. You see the white part, which represents the north, which, let's walk over here. Let's walk away from the magnets. And let's see if we're doing good. We're doing good. That's the north wall. All right, so 8 people on here. Good time in 8 people, because we're getting ready to get in some cool stuff. We got a Tesla coil that the primary is getting fired off the PMH. The PMH is reacting off the wheel turning from it, okay? The 2 ends of I got 2 wires that wrap around the whole thing. 66 turns. What's going on, Abwan? Hopefully I said your name right. Welcome aboard. 66 turns per, and they're turned so they would naturally be whatever pole they are, they'll increase the pole instead of beat it down. So we're going to come over here, we're going to look, and that's the north pole, and I just happen to have north in front of it. So the field lines are running out of this north pole into the south, out of the north into the south. And that's the direction that we're having. And so the main thing I want to show you about this is that when you take, just say, an iron bar, and you would think that you would spin the wheel. Let me see. If we just spin the wheel and we have iron, and it's attracted to the iron. This is good. Hey, Jason. Jason in the house. So if you have iron, you would think that this, because it's moving, you got momentum, that it should keep going. What's going on, Brian, big guy? Woohoo! So that it would keep pulling, right? And keep wanting to turn. But the reason that it doesn't and just give it a good spin. Going on, William in the house. Give it a good spin. But the reason that it's gonna slow down is look at the direction of what's going on here. So you're having field lines come out of the north, and they are going to be slowing down as resistance every time. If my thumb was one of those metal bars, and if it had a coil on it for opposing, that the opposing approaches on the opposite end. So you'll build in a natural resistance. On the iron, you don't. You're just going to get a natural kind of pull me, push me, I think, without the resistance. Now, you see the wheels slowed down, right? So the important thing is that you can see that on the wheel itself, it's not designed or set up to really be like a wheel that turns on its own without something being changed. Some dynamics have to change because you'd have to have a makey brake going when it's head on, because if my finger right now was the opposing, say the South Pole facing the north, everything you see field lines would change because now they wouldn't be going that direction or that direction. They're coming towards me instead. Let's go ahead and finish the connection. So we come out of the PMH, we're in the primary. Now let's move this back up instead away. I'm gonna move it close because the field lines are coming out perpendicular is the electric. So the electric is going to run up the wire from it being snapped back and forth and changed from the primary. This is pretty cool stuff because the primary is AC, getting hit AC. Like sort of like a wash machine in agitation. And then the secondary here is going to light up the LED inductively just from the primary being hit pulsed from here. So what is this going to show us? And this is short term because I'm going to show you guys, not on this video, but my next video or two, where I'm sending it wirelessly from one end to the other. And I think that's the important thing too. So let's go ahead and just turn down a little light. Now, this is not like high voltage, I'm saying, because I can definitely increase this, but right now we're just going to start it. So right now I got the wheel turning. The LED is not on. And we have everything hooked up except for what? We're coming out of this into the primary, coming out of the secondary. I think this is going to come off. I think we're going to take electrostatic plate on top. This is just an aluminum plate. We're going to connect a piece of wire, the green wire, and that's the end of the green wire. Going to stick that on top. And then we're going to come back to what the heck did I have hooked up? I think we're coming to that side. And then I think we're grabbing another aluminum plate. And we're going to go to this side. So what we have here is, we'll stop with, so we're going to go ahead and we're just going to turn it. So we're going to see what makes the LED light up. So right now we have a magnetic field going by the secondary. The primary is getting pulsed every time this is doing a change of direction. The back EMF is hitting that primary. So we're going to go ahead and we're going to touch the plate. Hold on tight. We'll see what the heck I hooked up right or wrong here. So dun, 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 dun. This is like my good inspired guy, Julius Sumner Miller. When something don't work, he just keeps pushing through. So I am going to put you on my little tripod, and I just had this son of a bitch and lighting up, and it was the coolest accomplishment, I thought. So you guys are gonna hang tight there, and I am gonna figure out what did I not hook up or hook up. So we got the PMH coming out into the primary. You know what it might be? It might be the primary. This is very important. The primary wires might be going the wrong way, so I'm switching those right now. That'd be some shit. There it is. It just lit up. Oh, yee, woohoo! Now listen, any of you guys that work with Slayers, you know that if you have the primary going in the wrong direction, what happens? Your lights don't light up, right? So right now, I just went ahead and switched the primary coming in. So basically, the primary of the secondary. Yes. So watch, the LED ain't lit up, right? Now we need just a wire, and we're going to come off of the conductor that's on top, and the end of the conductor. We're going to go ahead there it is. So let me get faster. So I just touched her. Look, the lights are lighting up. Let me turn this light off. This is lighting up from. Look at that. That's inductive. That's staying lit. Not that bright, but right there. It's a blue light bulb. So that's being lit up just from the wheel turning and going by the secondary. And you have to have a little capacitive reactance on top to get it to go. And I know just from it showing up, so I'm moving this capacitor, watch. Wherever I put it in a certain angle. There it is. What am I doing? See it lighting up? That is so cool. So we're picking up one just from the wheel turning on the Tesla coil here. Look at that thing. So, all right. So I'm moving it, and wherever I place it, in some places the light lights up. Let's go back to that. Let me get the wheel turning fast. All right. What was that all about? Here's the light. I'm just going to move it around. Nope, without the capacitor plate, I don't do shit. The bulb's lit just a bare, though, just a little bit. What the hell? So I'm wondering if I'm touching ground. Is it me? Some, if you see that just going on and off, I don't know if it's the angle. I think I gotta get back to that plate. Grab that other one. It's hard even seeing here. So, go back to grabbing this plate. So, we're getting this LED to respond just because the 90-degree turnoff from the electromagnetic field coming from the magnets that are running into the coil, and they're switching every time the wheel goes by it. So sending that signal out of this thing is no big deal. Gotta get this wheel turning, because as soon as you bring the aluminum in here as another inductor, it really reacts good. Especially when you start to see the LED light up. It's like I'll move it around. There it is. Look. There it is. Look. All right. We found the G spot. Woohoo! So this is a reactance off the inductor. Let's get it to go again. This is a reactance. Let me get the wheel to spin a little faster. So look at that thing lighting up. I just got it sitting right there. So this is coming just off the secondary of that secondary. The primary is connected to the PMH only, and that's the only thing we got going. Look at the LED lighting up. The key thing is this. We have an inductor. Look, I'm shaking the inductor in the air. Look, if I shake it in the air, the light goes on and off. Look at the reactance off the magnets that are flinging. I'm going to go ahead and just look. See that? Look, you can see where I have it. Look, the LED back there just going on and off like crazy. So when we're getting to that 90-degree angle from the magnetic field from the wheel, that LED is lighting up off the secondary. This is crazy cool because now you can tie in the black boxes. You can tie in the tripods. Look at that. I'm moving this. May have blown the bulb. No. So over the clovers have some good reactive area coming off of here. You can see where I'm putting it, and you can see that if the LED lights up, all right, so I'm gonna get a little speed back on the wheel. Look how all of a sudden now the LED's wide open. So what is going on here? All right, so here it is. Look, so the end part is leaning towards the magnetic field off the coils. It's making the LED react. because I almost completed electromagnetic induction closed circuit between. Remember, the primary is being fired from the PMHs. The secondary is an inductive. It's not connected just to itself to the LED. That's it. I'm coming off the one leg of the PMH and just letting the wire dangle like an antenna. That's the antenna. This antenna is reacting back to the transmitter. It's like the tail end. It's like the receiver and the transmitter. Let me see, because look, the LED's lit up. You can see that. This is crazy. So the LED is lit up. Here's the transmitter and the receiver. Look how they're acting back together. Look, I'm moving it away, and the light's stopping. Look, now I'm moving it closer. The light's going on. Further away. So we're going to pick right now. I'll tell you what I see going on. We're moving into its nodes. So it has its harmonics between the distance of speed of the wheel, the distance between the transmitter and the receiver. Look how it's lighting up as I bring it close by. So let me get the wheel turning faster. And what we're going to see is we're going to see the light up and then go off and light up as I move it. And what that's showing me that there's nodes that I'm hitting in the wavelength that it's putting out. That's the electromagnetic wave that is pushing it out, guys. This is cool damn stuff. Let me get the wheel going. So it's turning fast now. Look, I'm already back here. Oh, look, now I'll move closer and watch, it'll go on. Wow, I hope we didn't burn it out. I think we burned it out there, guys. Oh, no, it's lighting up again. So I had to bring the receiver over closer to the field coil. Look, now it's on. So let's do this. We need that. I'll tell you what we do need. We need to expand the antenna. It needs aluminum. My aluminum disc. The wire off one side of the PMH comes the antenna. All right. So let's go ahead and start this process over again. So we're going to turn the wheel, get the wheel turning. All right, wheel's turning. So the blue light is being pretty fussy right now. I don't know what's making it fussy. I think the blue light's gone. I need to put a better bulb in there. This is cool stuff. Hopefully you guys enjoy. Turn the light back on. Many more to come. I got some cool magnetic experiments. What I realized is back in the day, they were doing videos that are showing up on YouTube of using an iron pipe. And they would put they put a big coil ring around that pipe, right? And they would put AC to it. And they would put aluminum near it. And that aluminum either would repel, or if the aluminum was heavy enough and you layered the aluminum, keep putting layers on it, you can get it to levitate in that area. But what that showed me was the field direction of how the magnetic field is running and how the electric was running the opposing way. In fact, on that experiment I seen, you had electromagnetic shooting out this way, and the electric was running this way. So that's why the aluminum was repelling. So it's got me thinking a lot, and it's opening up my mind into these other experiments because I mess with Tesla coils a lot. And to be able to just come off of PMH and have an event, and we're not even like upcharging the voltage to come out of here. Imagine having coils all the way around here and they're all looped together, and you send a big ass pulse. You could definitely put electromagnetic field out to any device that you have in the proximity, is all I'm saying. You definitely can and always will be able to. And that's just by understanding how this stuff works. And that the PMH off of one leg is an antenna. That's mind blowing. It blows my mind. I think I blew the antenna, but look, so now it's crazy. It's huh. More investigations is all I got to say. You guys have a great night. Peace out. Leave your comments. What happened? Did the video go out? Did the video go out, guys? Okay. But anyway, you guys have a good night. The next one that we're going to get into will be I'm building PMHs that go all the way around. Really? The last 3 minutes? No way. The last 3 minutes was great stuff. Maybe you have to go back and watch the video. It'll show up, I'm sure. Sometimes it gets blacked out from you. So the PMH is all the way around. Some are field magnets, some are just coils. The coils will be gathered up and separated and pulsed into a Tesla coil, which will have a resonant frequency about the coil. Now the coil, this one's being pulsed off a primary. That is insane. Here's your primary. I got about 8 turns of some, I think 14 gauge braided wire. And that primary is pulsing and making this LED light up off of the wheel passing the copper. So the copper, you would have a magnetic field coming out, coming around, coming out, coming around. So the magnetic field is doing this and turning. So the copper wire is not in a 90-degree angle of it. But somehow, I don't understand this. To me, this would work better if it was this way. The field lines would be cut. But that's not what's happening. It's got to be that can be a way, and then the fact that the primary is being pulsed, and let's try this again, I guess. Jesus. So we're going to go ahead and get this fired up, and we're going to tie into a little antenna. I think the damn thing was touching. So no, the light bulb ain't lighting up. But if I bring this closer, let's see if we can get it lit. I may have burned the bulb out, but Here it is. Just lit up. What the hell? Here it is. All right, so, son of a bitch. So let's move this thing back now and see if we can get it lit. All right, let's see if, I think it's lit. Not really. Let's move this over. We'll know if it lights up. No. So let's move the coil back closer to the wheel now. Let me get a little bit speed back up. Now let's move it, the aluminum close. Of course. Let me try one more thing. See, I don't freaking give up. I got another idea. Let's throw another wire from the other side of the primary. There it is. So I got a bad connection here somewhere. So here's the antenna down bottom. Here's the antenna. I'm gonna lay the antenna down just the table. So it's touching more metal. Here it is. So let's get this light off. So somehow it is wavelength. I don't think I can stay connected there. The funny thing is, like, yeah, it's a bad connection. That's coming from that secondary. All right, I'm gonna get a little deeper. Obviously not tonight. Picking up on the secondary, throwing into the primary, sending out signals. That's what it's all about. Peace out, my brohams. Leave your comments.